All right, we'll see what happens there.
Sounds good.
Welcome, folks who are coming into the room. We're really glad to have you here today. Sam and I are very excited to talk to you about Colandr. We're going to give attendees just a couple of minutes to come into the room. So it's 5 o'clock Eastern time here for me. So we'll plan to get started around 5:02 or 5:03. Welcome, folks. As you come into the room, we're just going to give registrants a few minutes to come in and get started. So we'll plan to start around 5:03, so in just about a minute or two here. All right, welcome everyone. We'll just get started in 1 minute. So last chance to refresh your coffee, refresh your water, and we'll plan to get started in just a minute here. All right, let's plan to get started. So welcome everyone, whether you're here with us live or you're watching a recording later. We're so excited to have you here today and to be talking with us about Colandr, and particularly what the heck is Colandr and how can you now contribute to this open source tool and be a part of our community. I'm really excited to be talking to you today. I do want to note for attendees who are live, we are recording this and we are intending to archive this within the Colandr community as a future resource for future collaborators. So noting that this is being recorded and anything that is put into the chat will be saved. So your questions will be saved, chats will be saved. We are glad to also answer questions by email or to connect asynchronously as well. So really thrilled to have you here today. My name is Caitlin Augustine. I'm the Senior Director of Product at DataKind. And I myself was a volunteer on Colandr way back when, back in 2014, I think was our first team meeting. And we worked pretty diligently for a number of years and ultimately released Colandr in 2017 in partnership with Sam and her team out of Snap and NC. So really just thrilled to be here today. Sam, do you want to give a quick intro and then we'll kind of move on through our slides here?
Yeah, sounds good. Hi, everyone. Thanks for attending. My name is Sam Cheng. I'm a biodiversity scientist at the Center for Biodiversity and Conservation, which is a research center at the American Museum of Natural History, also here in New York City. I worked with Caitlin and the team at DataKind, and it's been really great, working with them to develop Colandr and seeing all the amazing things that they're doing. And we're thrilled to engage with all of you on this next phase.
Yeah, so what we're going to talk about today, so Sam, if I can get you to click ahead. We're just going to give you a quick introduction to DataKind and to the American Museum of Natural History. Our two teams that are keeping Colandr moving and are leading the Colandr community. We're going to talk a little bit about why Colandr. We're saying Colandr so many times. Well, Colandr, we named as such because it's a tool to sift through evidence to find those helpful pieces of information to drive data-driven decision making. So we're going to give a little bit of the background as to why is this tool important? What the heck is this tool? What is Colandr? And then what do we hope for the future and how can you help? So we're going to take you on the arc of Colandr and wrap up with how can you contribute and what are we looking to do in the next couple of years. So with that, I'll just give you a quick background as to DataKind. So DataKind itself, we are a global nonprofit that is focused on using data science, machine learning, and AI in the service of humanity. And we do this through partnerships with social impact organizations. So DataKind, we bring together a network of pro bono data scientists, 20,000 strong across the world. And we work to identify wicked problems that don't have a clear end solution. And that our real focus is, can we tame these problems? Can we find a way to mitigate some of those negative impacts? We work with a social impact organization to scope out what a reasonable, helpful, sustainable solution could look like. We put together a team of experts to work on that, either for days, weeks, months, years. And at the end of the day, we deliver a product, and Colandr is the output of one of those projects. The way that we work, we work through, I mentioned, hours, days, weeks. We do this by recruiting social impact organizations, identifying those data and AI opportunities, recruiting and managing those teams of experts, and staffing them through projects that are like data dives, which are weekend-long social impact hackathons, discovery days, which are one-on-one consultations with social impact organizations, or data core projects, which are a long-term engagement that can range from 3 months to 18 months. And then at DataKind, we stick around to ensure that solutions are used and impact is achieved. And so we don't just do a tech transfer and stop the work. We are intensely focused on ensuring that our solutions are useful, which is why we're here talking to you about Colandr 5 years later. DataKind, we are a global organization. We have chapters in 5 locations, and we're headquartered in New York City. And we've done over 300 projects around the world with nearly 200 organizations and provided almost 300,000 hours of pro bono data science services. So we are really thrilled to be talking about Colandr today as one of the numerous projects that DataKind's worked on, and really one of the flagship projects that we've deployed into the world, and we're thrilled to see that it's still going strong 5 years later. With that, over to you, Sam.
Thanks, Caitlin. Whoops, sorry, having a slide issue there. So I'm calling in from the Center for Biodiversity and Conservation. And as I mentioned before, we're a research center at the American Museum of Natural History. This research center, really focuses on bringing together robust and credible evidence from multiple different sources and different types of knowledge to bear on these complex conservation challenges that we're facing, from things like global climate change to equitable conservation and sustainability. And as part of this research center, we have a program called the Evidence Initiative. And so we serve as an organizing hub for evidence synthesis efforts, within the conservation and environmental space. And we really try and aim to bring together scientists, practitioners, policymakers, local community members, and educators across this entire area to try and not only use evidence to answer different types of conservation challenges, but to generate it and assess it and understand how we can apply it in more efficient and in more effective ways. And as part of this effort, we are part of the Collaboration for Environmental Evidence. So this is a global network of centers that brings different experts together along with evidence synthesis methods that I'll talk about a bit in a few slides, to really try and understand, what do we know about what we think we know in terms of the evidence for impact on what works, what doesn't work, how does it work. And as part of the center, we bring together different types of groups to really start to scope these questions and figure out where the evidence exists, assess that evidence for its rigor and its quality, and then help people figure out creative ways that they can apply it to their problems. And part of our sort of purview in this space is bringing to bear on these types of issues, different types of innovations and tools and methodologies to make this evidence more accessible and really integrate it into the entire sort of fabric of how we make decisions in the environmental space, which leads me to talk about Colandr. So in this section of the presentation, we're going to just talk a bit about the origins of Colandr, why it exists, what it can be used for, and why we created it. So, I think as Caitlin said, in 2014, there was a group at the Science for Nature and People Partnership, which is a collaborative working group structure at the National Center for Ecological Analysis and Synthesis, or NCEAS, in Santa Barbara, that was asking, how do we actually find the evidence we need to make better decisions in conservation? And once we find that evidence, how do we communicate it? How do we actually use it in practice? And, to really start that conversation, we need to understand what is evidence in the first place. The word evidence, we hear it a lot. We hear it in the news, we hear it in the day-to-day, we hear it in courtrooms and TV shows, and we hear it in terms of how we make decisions. And so what we can consider evidence can be multiple different types of knowledge, whether that's knowledge from research, knowledge from experience, from working in a space, knowledge from local perspectives and local knowledge that's been generated over many years. And just, our general understandings of a context. And what we can do then is bring together all of that information to make an evidence-informed conclusion about what we should do in a certain situation. And in this presentation, we are primarily focusing on evidence as it emerges in primary research literature and in grade literature, or these reports and these working papers that come out of different organizations and documentations about what we've done and what we know about it. And, when we think about this type of evidence has been generated at really, really exponentially increasing rates. There are reports coming out that scientific literature is increasing exponentially every 9 years. So there are millions of potentially useful research papers and reports out there that is just continuing to rise. So, what we're sort of facing as decision makers is, how do we actually dig through all of this? We're sort of buried in a deluge of information. And whether you're making decisions about what research to pursue or how to make a decision about what kind of program you want to implement, it's really hard to be able to go through all of this and keep up and make sure that the information you're using is updated. And, there have been reports out there that even though we're generating all of this information, is anyone actually even using it? And so this report came out in 2014 in the Washington Post, where there was a report from the World Bank, who funds a lot of different types of development and environmental projects around the world, that stated that out of all of the hundreds or thousands of reports that are generated every year, only about a third are ever opened from the repository, which sort of brings us to the question, have we already figured out what we need to do? Or do we already have the information we need and it's just buried in a PDF that no one can find or, much less read? And so there really is this need, and not just in the environmental space, but across many different types of sectors, for people who are, working on the ground, practitioners, to really be able to access the insights from all these different types of research endeavors, whether they're from academic research or from grade literature, in order to pursue evidence-based or evidence-informed decision-making. And not only do they need access to it, they also need a framework to follow to create the resources that bring all this together, to assess its quality and make it accessible and usable. So what's the solution then to this problem? So one solution is through the practice of evidence synthesis. And what evidence synthesis is, it's a diverse set of methods that are used to scope and to bring together, collate, review, and to synthesize and communicate the best available relevant knowledge on a specific topic or a question. And the value of using these types of approaches is that they're systematic. So they follow a very clear set of guidelines and methods. They're transparent and they're reproducible. And so that the ways in which we look for information, we bring it together and we synthesize it are done in a way that's really clear. And that allows us to minimize and account for potential bias that could influence how we do this. And what they aim to do is to capture a really comprehensive, if not exhaustive, picture of the body of available evidence in order to make statements about what we know. And evidence syntheses can come in many different forms as are listed here, and I won't go over them today, but this is just a taster of what's out there. And so for evidence synthesis, there are three main organizations that are global that set the guidelines for how to conduct these types of methods for different fields. I spoke a bit all about the Collaboration for Environmental Evidence already, or CEE, that sets these guidelines for the environmental sector. And the other two are the Campbell Collaboration, which sets the guidelines for social sciences, and the Cochrane Collaboration for medicine and public health. And generally, all of these methods are characterized by a set of steps. The first being actually scoping and defining the process. What's our question? How are we going to look for information? Where are we going to look? How are we going to look? And how are we going to assess it? And then you go through and you conduct your search strategy. You find the information. You assess it for relevance. You extract relevant data. And then you analyze that to answer your question. While these approaches are widely used, and in some fields, for example, in medicine, they set the standard of practice for guidelines on what to do for medical practice, for example. But the challenge is that as useful as these methods are, they can be extremely labor intensive. If you recall, when I mentioned earlier, we are producing millions of research papers a year. So to be able to keep up with that can be really labor intensive and really costly. And a paper recently started estimating some of the costs and the time required to do some of this work, and they can be quite cost prohibitive. And what's more, the time it takes to do these well can make it difficult for them to be able to inform the types of challenges that we want these syntheses to help and answer. The second issue is that the process by which we actually do syntheses is actually quite messy. As you can imagine, you're bringing in lots of information, you're working in collaborative teams, you're trying to keep data clean and organized and reproducible. But in reality, when you start to look through how people are managing this process, everyone's doing it in a slightly different way. And so, while we try and use synthesis to make the evidence base more accessible and make some structure of the pile, we actually end up with things that are a little more complicated than we probably want it to be. So, kind of getting into these spreadsheets that get even more and more hard to navigate and difficult to open. And so to answer some of these issues, there are tools that have been developed. There are different types of reporting tools, different types of platforms that are used for evidence synthesis. But the challenge is that not all of them are well suited for all different types of topics. Some are specifically created for certain topic areas such as medicine, while other ones are hidden behind paywalls, which make it hard for different types of groups to be able to access them, and to make it cost effective for different types of teams. In addition, a lot of these tools remain dependent on manual processes where an individual or a team is manually going through every single step. So what we realized with our team is that we really needed a better solution. And we came to this partnership with DataKind with a really big question of how do we actually tackle these huge systematic syntheses, especially when we're asking big questions. For example, questions about the global state of evidence. And then once we've completed them, how do we actually update them? Since new research is being published every year, we want to make sure that these syntheses are responsive as situations change and we learn more. And so this project started when our group at the Science for Nature and People Partnership, who had been working under the leadership of Conservation International, came with this question of, well, we created this entire evidence map of the existence of global evidence on the links between conservation and its impact on people. And for context, a team of 2 people read through 35,000 abstracts. So the titles and a short summary of each paper to take that down to about 3,000 included papers that seemed relevant to about 1,000 that we extracted relevant information on and sorted through. And that process took us 3 years. And at the end of those 3 years, under the guidelines, which we were working with the Collaboration for Environmental Evidence, the guidelines state that we should update our syntheses every 3 years. So the minute we finished, we realized we would have to do this all over again, and we needed to find a better solution. And so working with DataKind, we started thinking about how we could help users find evidence faster and to provide functions where they could intelligently sort through this pile of information. And then after we've sorted through that pile of information, if you recall, we went from 35,000 abstracts to about 1,000 papers. And so even those 1,000 papers represents a huge labor-intensive load where we wanted to find some way that we could assist with sorting and labeling those documents into different types of categories so we could better analyze the trends that we were seeing. And so what we came up with was Colandr, which is an open source, open access online platform for document reviewing. And I'm going to turn it back to Caitlin to talk about some of the machine learning and text mining algorithms that are present in Colandr and the functionality.
Yeah, totally. Thanks so much, Sam, and thanks for that overview. So as Sam mentioned, DataKind partnered with the SNAP research program led by Conservation International with this idea that there had to be a better way to do evidence synthesis, that the status quo of having tool-based solutions that were often behind a paywall or for a specific sector of research was not going to be a useful long-term model for this, nor was it going to be satisfactory to simply use generalized tools such as Google Sheets or Excel files as a manner of tracking your evidence, seeing how complex that type of information can get when you have many actors. So at DataKind, we said, we think that there is a way to build a tool that can apply machine learning and data science to this approach. And what we ultimately, realized that, yes, we are data scientists. We wanted to be data science positive. We knew that at the same time, algorithms that were a black box were also not going to be sufficient in the research space. So when we built Colandr, we built it to intentionally be an open source, open access tool so that you can actually see what's happening under the hood. You can go to our GitHub and you can pull down the actual processes that are occurring. And we built it so that a human is in the machine at each step. So a human still has to do accept or reject through each step of the process. Now, the front end itself, which you can see a screenshot of, and you can also go directly to the link in the chat. This was built in HTML5 and with Node.js supports. And it makes API calls to these 2 systems, System 1 and System 2, which you can see in this framework here. And System 1 and System 2 are the 2 different machine learning steps that your evidence will go through in this process. And this is built in a host of languages, from Python to Scala to using Tesseract and PDFbox to extract information out of the PDFs, and with a backend that's a PostgreSQL database. And how the data actually flows through this process. So you start with your citation import. And this is where we bring in information. If you want to just go to the next slide, Sam. We can bring in citations from multiple formats. You can bring it in a text file, RS file, bibtext, but you as a user have to start yourself. So Colandr, it does not have a database search built in. There's legal and copyright restrictions on that. But if you have done a search for a citation in a different system, you can import those files into Colandr. And then you can build out your review, and you could set up your collaborative work process with your team here. So you can set if there are single reviewers, if there are double reviewers, you can go through each step of your systematic map or systematic review process and lay it out within Colandr before going into the first machine learning features, which are in System 1. So System 1 is our first screening step, and it screens on citations, authors, and abstract. And there's a feature here that is the first really unique feature of Colandr. It's the relevance ranking, and this can be toggled on or off. So this is an opportunity for a word-to-vec algorithm to learn from your processes. So it takes your user-defined search terms and it computes the amount of overlap between those terms and the preliminary review of the information for then a human to end up deciding to include or exclude that citation. And every 10 citations that a decision is made on, the algorithm learns and it updates. And it assesses based on that complex classification approach, which is a distributional word vector. Word2Vec as a process, it is actually published in 2013 by a team out of Google. It's a family of algorithms for natural language processes. What it does essentially is that it represents each word as a vector and computes the relative distance between words in the corpus in order to find the semantic similarity of those words or phrases. The Word2Vec model and these outputs are used to then do the ultimate categorization of the new text data that comes in. And what this has done is going from a search process where a human would just say, start reading in a list that's been alphabetized and might find 7% of those citations to be included in their ultimate systematic map. By using Colandr's System 1, you find that up to 40% of your citations could end up being found in your first 250 reviews. So it is a way to really surface evidence more quickly. In that overall process, your citations are ranked by expected relevance. Again, you can turn it on or off to move forward. Now, in System 2, which is secondary screening and metadata extraction, as a user, you're prompted to upload the full paper for this screening and extraction. The PDF is converted into text for analysis purposes using Tesseract. So extracting evidence in this step, which is often called metadata by your reviewers, it usually requires a reviewer to read an entire article and manually code for those desired features, which might be things like the geographic area of coverage, the type of conservation method being assessed. Our System 2 within Colandr was designed to make this process frictionless by providing processes for semi-automatic metadata classification. And the way that it works is that it extracts sentences from articles that it identifies as relevant to the desired evidence tags. So what you as a user have identified as relevant. For location features, Colandr uses named entity recognition, which is a technique to find mentions of locations and to suggest those as labels. For all the other metadata, Colandr relies on global vectors for word representation, which are these which is also called GLUB, and then a logistic regression to train a model for ranker tags. And with that training system, the training system potentially over-predicts. It predicts a sentence from a large number of labels so that the system itself can actually focus on recall and the human annotators can focus on precision. And this is important because we want to give a human ultimately the chance to accept or reject particular tags. So Sam, if you want to click ahead to the next slide, which will actually show a confidence level, the confidence level that our system is predicting for each of these particular tags. So we're saying that within Colandr, we are confident, we have a certain level of confidence that this sentence is applied to the particular tag that we are looking for. And again, this learns after every 35 sentences that have been tagged for inclusion or exclusion. So that's a little bit about how Colandr works on the back end. These two different systems that are different types of natural language processing models that rely on a human, again, to accept or reject the information that the algorithm is spitting out, and that the systems learn over time and take in information. What I'll just add before handing it back to Sam to talk about where we're going in the future is that these algorithms are intentionally, they learn from every new model. So if I were to build, or every new study, so if I were to run a systematic map today on an area of interest to me, say I wanted to do one on the data science for good space, Colandr would work for me and it would learn for me and my system, but those learnings don't pass on to Sam if Sam is going to start a review in, say, her area of study in like cephalopods. So Colandr learns and performs for each individual user and study. So the results are relevant to you and the work that you are doing. All right, back to you, Sam.
Thanks, Caitlin. And thank you for mentioning that. That's a really good point. One of the challenges that we'll talk about briefly next is how you actually use these tools across many different domains. And this came up because after we launched Colandr in 2017, we'd initially designed the tool to answer a question within the conservation and environmental management space. What we discovered is that we were actually answering a need that was present across the entire sort of decision space for people wanting to use evidence in the types of decisions they want in their sector. And so since 2017, we have built up a user base of over 4,000 active users who are engaged in nearly 3,000 past and ongoing reviews of all different sorts and all different topics. Colandr has been cited in over 50 publications that have been published so far. And it's really been used by groups, from really diverse sectors, within the conservation and environmental space, but also within medicine and public health and education, and by users across almost, I think the last I checked, over 30 different countries around the world. And that's something that building this tool as an open source and an open access tool that's online has really enabled us to do, is serve as a service to those who are interested in using evidence synthesis methods, but may not have sufficient resources or unlimited resources to use some of the more pricey options that are there. And as we went through this process and as we've been managing and running Colandr since 2017, there have been various things that we've learned. First is designing something that is, quote unquote, commercially competitive, but at a nonprofit cost or an open source cost. Like I said, there are many tools out there and new tools are coming up all the time. And so from a management and development perspective, we're really trying to think about how we deliver the best experience for our users and to provide, very reliable functionality and to answer user needs while doing it in a way that allows us to remain open access. And this leads to our third point here about tempering expectations. The intent of Colandr is to make this process more efficient, but it's not necessarily to replace ourselves as experts, as evidence synthesizers, as decision makers, as the primary decision-making point within these, because it is important that we understand the provenance of the information that we're looking at, and also because we're all answering different questions and we all have different needs for different types of information, and we all have different levels of acceptable risk, which means we might be looking for different bodies of information to draw from. Another challenge that we've run into is on the technological side. How do we know when the machine learning algorithm is working optimally, particularly when we're working in a space that perhaps is quite nebulous in terms of the types of words that we're using to describe what it is that we're interested in finding? So I'll give an example here. In the medical field, if we are interested in understanding the types of treatments that are effective for treating influenza, there are only a certain number of terms we would use to refer to influenza. It could be influenza, it could be the flu, It could be, a scientific name for a more specific strain of influenza. But in our space, in conservation, that semantic sort of variability is much higher. So when we talk about even the word conservation, many people say to me, oh, do you work in archival research, in the preservation of art and other types of materials, which certainly is a type of conservation, but we're talking about nature conservation of natural ecosystems. And so those are the types of limitations that we're working with, hence why we built Colandr to have a person or persons remain part of that process. Other issues that we've run into as well is whether or not Colandr can be adapted to work in different languages. Right now, Colandr is only tailored to working with text documents in English. But we know that lots of information is being generated in other languages. And so how can we broaden the usage of Colandr and its utility for more people around the world in that sense? So some of the more specific topics that we've run into issues with that we're looking for help on today and during the Hacktoberfest is getting some thinking around some of those big issues that I just introduced, but also around the day-to-day functions of the tool itself. As Caitlin mentioned, this was built by a DataKind volunteer team from 2014 to 2017, and by a team who probably thought they were engaging for a little less time than they ended up engaging for. But through their fantastic efforts, we were able to build this really awesome platform. And over time, we've been able to grow this community of practice where we've had different users provide little add-ons to help sort of improve the Colandr experience and to add additional functionality. And we've had the wonderful support of the American Museum of Natural History in helping host Colandr and my time to help continue to run it. And, despite that, as we move forward, we do have issues that we would love to get development insight on and help. Some of that is addressing major bugs, little twitches in the front end and some issues on the back end that, if improved, would really help the performance of the overall tool. Insights on how we improve the machine learning and the text mining functions of it, as well as, providing more training and more guidance on how to address certain issues within the platform, how to set things up, how to tailor the platform experience to your specific project and team. So I'm going to turn this back to Caitlin now so she can talk a bit about how you can all get involved to help us answer some of these questions.
Yeah, so for the rest of the month of October, so the next 7 days, Hacktoberfest is happening. And so if you're a developer listening to this and you're eager to rack up your points on GitHub, please join us. Register for Hacktoberfest, and then please start contributing to Colandr. And you can contribute to Colandr in many ways. So we have started just adding our whole wish list as issues within Colandr that you can start to tackle. You can tackle them partially. You can tackle them in their entirety. You can add to them. So these are issues that are broken up by level of severity of how much impact does not being able to do this have on the Colandr user base. So you can see that some are, hey, they're not so severe, but maybe they're a really quick fix, and please, we really want that. Maybe some of them are really, really meaty, and the solution's going to take multiple days, multiple weeks, multiple months, many pull requests. That's great too. We're eager to have your thinking against these solutions. So for example, Sam mentioned a real challenge is that Colandr right now only reads, is only useful for English language research. Now, it's possible that to make Colandr work for non-English language research, it would require building in new algorithms, new approaches, a completely new Colandr. And that could be a really exciting challenge, but we don't know where to start. So if you're interested in natural language processing on non-English languages, please, create an issue, share your thinking with us about how to start approaching that project so that we can add it into our product roadmap. If you are someone who is interested in low code or no code solutions, Sam mentioned that we need a lot of documentation. So a number of these issues can be done just if you want to create a user account on Colandr and start going through and documenting what your experience is going through each step of building a process. So we would be really eager to have you there. Now, if you're a front-end developer, we need your help too. So we mentioned the front end is it was state of the art when it was launched. We need some updates. We're in an old version of Node.js. So if you are interested in helping rebuild the front end, adding in again additional features on our front end, we'd love your support there. We have a couple of issues that are just tagged of how the information flows in a particular screen size, to things that again are more complex about how do you manage the sign up infrastructure. So you can go into our issues, you can filter to your particular area of interest, you can identify type of skill you'd like to engage in. And again, if you don't see the issue that you want to contribute to, please add it in. Please keep communicating with us. We just opened a discussion board inside the Colandr repository, and we'd love to have you commenting there, engaging, sharing insights. We used to run a Google community for Colandr as a Colandr message board and exchange. We also have Colandr exchanges happening on Stack Overflow, but we'd love to start to centralize that. So please, as you have thoughts, contribute to the discussion as well. Again, if you ever have any questions, you can reach out to Samurai directly, or you can reach out to the Colandr team Gmail as well. And so I think, Sam, back over to you to kind of wrap up on what the Colandr community is. So.
Sounds good. Thanks, Caitlin. Yeah, and I mentioned this briefly earlier that we've been building a community practice around Colandr. And so really the vision is by having this platform that it wouldn't just be a one-way service, that we would really be trying to build not only the evidence synthesis community, but also developers, and start to build these partnerships between the evidence synthesis world and the users and people who are working in software development and in computer science to really understand how do we actually improve the space. And one of the ways in which we're doing this is through the Colandr community website. Off the bat, this website has a lot of the how-to and the guidance materials that are existing to help users navigate through Colandr and get themselves set up, but also provides links to read more about how you can partner as a research partner to try and understand some of the conceptual challenges around Colandr and some of the technical ones. For example, figuring out how efficient is it over the manual process for different topic areas, and figuring out statistical ways to identify stopping points of when you probably read through enough that the stuff left behind isn't that relevant, so you don't need to go through it sort of things. And then also a NABL community, which was the existing discussion board where you can see some of the existing discussions of issues, as well as frequently asked questions, where you can also get a bit of a flavor of some of the workarounds that we've created to adapt to some of the bugs that have happened and things we're looking for help on. Oops. All right. I think that takes us to the end of the presentation portion of this webinar. And I see that there are some questions in the chat. Caitlin, I don't know if you want to read them out or if you want to leave them there, but I'll just leave our contact info here. Actually, I'll bring us back to the original slide on how to get engaged for the links.
Yep, and I'll just mention we'll share out the slides here as well as the recording once it's completed. A couple of questions that have popped up in this webinar and others are really, things like what Jackie just posted, adding in languages. How would we determine what language? What is the importance of making non-English research accessible? I'll just kind of mention a quick resource I put in here, that non-English language, natural language processing. This is a really big deal, and it's something DataKind cares about quite a bit, because you want to think about the equity of the tools and the work that we're doing. And if we are building out toolkits that are only representative of one voice and one point of view, that doesn't align to DataKind's values and doesn't align to the CBC's values that Sam was laid out earlier about equity in science. And the Lacuna Fund actually just put out a fairly big analysis of some of the challenges and opportunities for machine learning in non-English languages that I'd encourage you to look at and look at their resources as an example of why we might want to build out that way. Now, is that a short-term plan? No, but it's important to start thinking of tool sustainability and tool utility and tool representation. So that is part of what we think of as the next phase of Colandr in the next 5 years. Sam, I'll ask you a question. So, obviously you've really been the steward of Colandr through a number of organizations and a number of deployments. And where do you see the opportunity now? What has kept you engaged here? What is the potential that you see, and why you're looking to another 5 years of this work?
That's a great question. I think it is a bit of, definitely in the beginning, it was a labor of love. But, over the years, and especially as our user base has grown, it's become really clear how needed this kind of open source and open access platform is. So from the open access perspective, going along with what you just said, Caitlin, about, issues of equity, being able to access and conduct, evaluations of evidence to help inform decisions is a critical issue that every single country and every single issue around the world needs. But when they're limited to platforms where, the cost, the fee to do them can be quite high, it really limits what people do. And so a lot of times I see organizations sort of fall back on sort of traditional literature review, which can be useful. But when you're answering we're trying to address really big questions like, how do we best address climate change, right? In certain scenarios, we want to make sure we're drawing on the best available evidence and we're not missing something just because we were short on time. And so we're hoping, and I think we've seen that Colandr can help move this forward. And so there's an opportunity here to make sure that this tool really meets users' needs and can stay alive and can stay usable and can stay responsive as those needs change and as people need to integrate information and go through it really quickly. And, do it in a way that's really transparent, because I think that's one of the other issues that we've run into is that, the value of doing evidence synthesis is that they're transparent. It's really clear how things were included, how things were not. And if we can improve the way in which the machine learning functions so it's even more efficient than it is now, I think we've got a really great opportunity to contribute to make this field, something that's really accessible and usable.
I think that's such a great note, maybe even to end on here, Sam, that we are looking to keep growing Colandr and keep it relevant to just really continue allowing access and opportunity to conducting this type of research and doing it in a sustainable, open fashion. And we really hope that you who are watching and listening to this webinar come along the journey with us. So be it through Hacktoberfest for the rest of October 2021, or as a longer term contributor in our GitHub and our community, we'd really love to have you.
Thanks, everyone.
Thank you, everyone.